Okay, so you can see my screen right now. So Samuel and me is actually talking about the Maths Festival. So for your information, because next week is a Maths Festival already, start from 20th. Okay, then that I posted the schedule. So this is a schedule of the competition. So there are few competitions already closed for registration. For example, the Maths. Round the block, Maths Mariel, and Sudoku. Okay. So when you click the link, if the link can't be accessed, means it's already closed for registration. Okay. So you can see the link is actually given here in the previous post. So if you want to participate, you just go to click the link. And if you want to know more about the games, you can click the link. When you click the link, you can see the description of the game. Okay, then you can know about the games. Okay, then you decide whether you want to join. So for your information, the registration of the Maths Festival will close by this Friday, midnight. Okay, so because we need to finalize the name list already for the participants. Okay, and for your information, among all the games here, right, only Maths competition is allowed for individual participation. So the rest of the games, you need to find your friends and form a group to participate. So for your information, I'm in charge of the Maths competition. Okay. Okay, yeah, the event is on start from next Monday. Okay. Okay, any questions you want to ask, then you can ask me again later. Okay. Okay, so let's start the class. Okay. So previously we stopped at complex number. We started a bit on the complex numbers, okay, for the intro, okay. Then today we will move on, okay. Okay, can any students tell me that you can see my screen?
Can, miss.
Okay, thank you very much. So remember yesterday we stopped at this slide, okay? So I asked you to practice these questions to get your answers in the complex numbers, okay? So from these questions you will understand where is the complex numbers come from, where is a square root of -1, okay? So when you look at this example, right, when you're solving it, you have a negative in the square root, right? So for your recap again, negative square root of negative 1 we represent as a I, or we represent as a j. So as I say, for engineering, we may using j to represent the square root of -1. But for others maths, right? Okay, for others area, it's very common that we're using I. Okay, so to avoid the confusion, engineering we using I as a notation for current. So that's why they may use J to represent the square root of -1. Okay, so remember, this is a general form, right? Okay, A plus BJ. This is a general form of complex numbers. Okay, can you still remember which part is a real part, which one is an imaginary part? Okay, so for A, is it real or imaginary?
Real.
Okay, real. A is a real part, yes. Okay, then the BJ is an imaginary. Okay, okay. Now, can you tell me what for the complex numbers, if I write as a plus BJ, what is a form? What is a form? What we call this form of the complex number. When we present complex numbers as A plus BJ, what we call? What is a form?
Cartesian.
Cartesian form, yes, correct, Cartesian form. How about another name? Start from R.
Rectangular.
Yes, correct. Okay, rectangular form. Okay, Cartesian form and rectangular form. This one you have to know very clear. Okay, so now let's move on. Okay, so you already know what is a complex number. So the next thing is we need to go through on how we deal with the j, the square root of -1. Okay, so for this slide, we will go through on how we deal with the j. Okay, so as I say, j is a square root of -1. Okay, now when you have j cubed, okay, when you have j cubed, and I think before come to j cube and so on. Okay, so let us discuss about this. Okay, so what is the j square? Okay, as we know, this one is a basic. You need to know what is a j square. So j is a square root of -1. J square means it's j times j. So j times j means square root of -1 times square root of -1. What do you think is the answer? Anyone?
-1.
-1. Okay. Okay. So maybe when you look at this, you get confused about the answer. So if we discuss about this, okay. So square root of 2 times square root of 2 is actually 2. Okay. Right. Okay. So that's why when square root of -1 times square root of -1 is a -1. So you have to always remember j squared is equals to -1. Okay. And we're using this concept to actually evaluate the following. Okay. So now start with j cube, right? So j cube is actually equals to j squared multiply j. And j squared, just now I already told you, is equals to -1. Okay, then with the j, then will be minus j. So because this is -1, so become minus j. Okay, okay, now j power 4. Okay, j power 4, we understood that is a j squared times j squared. And we already know what is the values for j squared, right? So j squared is -1. So when you multiply -1 and -1, you get +1. Okay, okay, next. How about the j power of 23? So now we deal with a greater power, okay, power of 23. So power of 23 is actually j multiplied with j power of 22. Okay, so when we have odd numbers of the power, okay, we will express it as a j multiplied with j power of 22. So here I get an even number. Even number of the power. So when we have an even number of power, right, I can write it as a j squared power of 11. So remember, when you have a j squared power of 11 means it's a 2 times 11, right, which is 22, right? Okay, so it's a j squared power of 11. So for j squared, okay, we understood that j squared is actually -1. So I can replace it as a -1 power of 11. Okay, so now when you have a -1 power of 11, what is the answer? When you have a -1 power of odd number, so this one is odd number, then what is your answer? Your answer will be negative, correct? Okay, so for your information, -1 power of n, if the n is odd number, right, then we will get a negative. So if let's say the n is an even number, right, then we will get positive. Okay, so for example, -1 power of 3, okay, is equals to -1 times -1 times -1. So this one must be a -1. But if let's say you deal with the power of 2, okay, so which is an even number, it will always give you a positive. Okay, so when you deal with negative number, power of odd number will give you negative sign. Power of even number will give you positive sign. Okay, so for this case, we get a -1 here. Then we simplify, it will be -j. Okay, okay, now, so next example, okay, we have d, which is -4 divided by j power of 9. So let's see what is a j power of 9. So again, j power of 9 is actually j multiplied with j power of 8. Again, okay, so this is a j, the other one must be a j power of even number. Okay, so this is a j power of even number. So for j power of even numbers of 8, so j power of 8. So for j power of 8, we will write it as a j2 power of something. So which is j2 power of 4. okay, because 2 times 4 is 8. So j2 power 4, and j2 is minus 1, and minus 1 power 4, as I say just now, when the power is even number, you will get positive. Okay, so that means this part you get a positive 1, then multiply j, you get j. Okay, so the j power of 9, we get a j. Okay, so negative 4 over j is our answer. Okay, so now this is our answer so far. Okay, so if we want to move on to simplify further on this, okay, so when we deal with numbers divided by j, right, okay, what we can do is we multiply with negative j. Okay, we multiply with some things with the opposite sign. Okay, so here is j, we multiply with minus j. Okay, so when we multiply with minus j, can you see the top and bottom is the same? So when the top and the bottom are both minus j, that means this is equals to 1. So it is fine if I take negative 4 divided by j multiplied by 1. Okay, it won't change the value. Okay, so minus j over minus j is 1. Okay, what happened when I multiply by minus j and minus j? So at the bottom, I will have minus j squared. At the top, I will have 4j. And remember, j squared is actually always equals to minus 1. So minus 1 times minus 1, you have positive 1. Okay, so that means you have a 4j, or we can write it as a j4. So I already discussed yesterday. So sometimes we will write the j at the left, or we can also write the j at the right. Okay, so the j representing square root of minus 1. Okay, so far can you understand A, B, C, D? Any question? So this is showing you how we deal with j. Okay, so in order to understand about j, so this is how we deal with j. Okay, so we just show you how we deal with j without the real number first. Okay, just showing you the j. So you need to understand this one. So before we go further. Okay, any question before I move on? The last part. The last part means j power of 9 or the last row. Oh, you mean this part, is it? Is it this part, the one that I put a bracket? Muhammad Saad, is it the one that I put the bracket? Yes, huh? Okay, so. Okay, let me erase it again and I explain it again. Okay, so now for the last questions, right? Okay, you need to find negative 4 divided by j power of 9. So from the beginning, we try to evaluate j power of 9 and we managed to get it as a j. So I substitute j power of 9 as a j. Okay, so now you have negative 4 divided by j. So how we deal with the division by a j? So j is representing square root of minus 1. Okay, how we deal with it? Okay, so we are going to multiply with the j also. Here is j, right? I'm going to multiply with the j by I inverse the sign. Okay, so which is minus j. And at the top, I also multiply by minus 1, minus j. So bottom minus j, at the top minus j. Okay, so when the top and bottom is the same, that means this one is equals to 1. Okay, understand? Y equals to 1. Minus j over minus j, because both are the same thing, so it's a 1. So when we multiply anything by 1, it's still the same things, right? Okay, 2 times 1 is still 2. Okay, j times 1 is still j. Okay, so we multiply by 1. Okay, so why we need to multiply by j at the bottom? Okay, so the reason is when I multiply j and j, I get j squared. And the j squared is actually giving you a values of minus 1. Okay, that's the reason why we multiply by j. Okay, because when we multiply by j, we get negative 1. Okay, so here we multiply by minus. Okay, so that means when the j square is -1, okay, the j square is -1, and -1 times -1, you get +1. So that means we have 4j divided by +1. So 4j divided by 1 is the same as 4j, or we can write it as a j4. Okay, okay, so at the top, how I get 4j? Because -4 times -j. So that's why 4j. Okay, so will it be better? Okay, the reason I multiply by j, because j square is actually giving you -1. Okay, then we can able to simplify further. We don't have a j at the bottom of the fraction. Any other question, Saad?
Hi, Miss.
Okay, yes.
Can I use j over j instead of -j over -j?
Okay, if I look at this case, right, okay, to me, j is still fine. Okay, if you have -4 over j times j over j, right, so I'm going to have minus 4j, and the bottom is a j square. So bottom is j square, which is -1. So -4 divided by -1, I will still get 4j. Okay, for this case, not an issue. You can just using j over j. But I know what is the reason they put a minus. Okay, later when come to the division of the complex numbers, then I think you will know why they put a minus. But as yes, correct. For this case, if you're putting j over j, is fine. Okay. Okay, so if you want to know further on the y minus j, so when come to later part, when we deal with the division of the complex numbers, then you will understand why. Okay. Okay, so let's move on. Okay, now, so come to the complex numbers. It can also represented pictorially. Okay, so this one you need to understand. So this is also very important. Okay, so you need to understand how we represent a complex numbers pictorially. Okay, so okay, in order to understand how we represent a complex numbers pictorially, so remember this is a general form of complex numbers in the rectangular form or Cartesian form, right? Okay, so we can also write it as x plus yj, okay? So if I write it as x plus yj, then it will be easier for you to get the ideas on how we actually plot the complex numbers on the Argand diagram, okay? How we actually represent these complex numbers pictorially, okay? Okay, so now when come to expressing or representing the complex numbers pictorially, right? Okay, so we define the horizontal axis, which is the x-axis, as a real axis. Okay, so when I say real axis, that means it's representing the real part in the complex numbers. Okay, then for the imaginary axis is the y-axis, right? Okay, y-axis. So for the y-axis, okay, so for the y-axis is representing the imaginary part. Okay, so if I write the complex numbers as x plus yj, then you can remember it better how you actually represent it pictorially. Okay, okay, so now, so what I'm trying to tell you is, okay, so if let's say you have z equals to 1 plus 2j, okay, so as I say, this is x plus yj. If I present it pictorially, okay, so that means on the x-axis, x is actually equals to 1 y is actually equals to 2. Okay, so say x is 1 here, y is 2 here. Okay. Then can you see this is x is 1 is here, y is 2 is here. So this is the point. Okay. Then this one is the, okay, your complex numbers. So which is representing 1 plus 2j. Okay. So representing 1 plus 2j. Okay. Okay, now, so let's identify, okay, what is the complex numbers for each one of them, okay? So let's start with A, okay? So A, can you see the real part? Real part is a 3, so that means A is equals to 3. Then for the imaginary part is J2, so which is plus J2. Or if I write it as 2J is also same, okay? 3 plus J2 or 3 plus 2J, okay, for A. Okay, now, how about B? What is a B? Can you put it in the chat box? How about B? What is the complex numbers? Okay, minus 2 plus J4. Yes, okay. So the X is minus 2, the real part. Then the imaginary part is J4, so plus J4, correct. Okay, then how about C? How about C? Okay, so C, the X is minus 3, yes. Then the imaginary part is minus J5, yes, correct. So C is minus 3 minus J5, correct. Okay, okay, how about, yep, okay. How about D? Okay, D, the X is 1, the Y is minus J3, so which is 1 minus J3, correct. Okay, so I think now you understand, huh? Okay, so you can see if you look at here, this is a first quadrant, this is a second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay, okay, so the answer you put is correct. Thank you very much. Okay, now let's move on. Huh? Okay, so what is about the next part? Okay, so you already got the basic idea on complex numbers. So the next part is how we deal with the complex numbers. Earlier is how we deal with the J. So now is how we deal with the complex numbers. So complex numbers consist of real part and imaginary part. How you add them, how you subtract them, how you multiply, how you divide them. Okay, so this is what we're going to go through here. Before we move on for the application, then you need to understand how we conduct the operation on the complex number. So we start with addition and subtraction. So addition, subtraction, the concept is the same. How you deal with the complex numbers for addition and subtraction. So say if we have two complex numbers, so which is given as Z1 and also Z2, okay? So how we add the two complex numbers just now, okay? So when we add the complex numbers, right, the real part have to add with the real part, the imaginary part have to add with the imaginary part. Okay, so when we look at the Z1 and Z2, right? So the real part from Z1 is A, the real part from Z2 is C. So we take the real part plus real part, so that means A plus C. Okay, then when come to the imaginary part, so can you see for Z1 there's an imaginary part of the JB, and then here is a JD. Okay. So we can't do anything with the J, so but we have B and D, right? So we take B plus D. Okay, B plus D, then J. Okay, so this is the how we deal with the addition. So same things goes to subtraction. So when come to the subtraction, again, the real part deal with the real part. Okay, so you can see the real part is A and C. So since this is involved subtraction, so A minus C. Okay, then for the imaginary part, we have a JB and JD. So when we deal with the subtraction, that means the coefficient, the values, which is B minus DJ. Okay, so we add or subtract separately for real and imaginary part. Okay, now, so you look at the questions given here. Okay, so you have two complex numbers, 2 plus J3 plus 3 minus J4, right? So this is a real part. So real part 2 plus 3, which is 5. Okay, then come to the imaginary part. We have J3 and minus J4, right? Minus J4. So J3 minus J4, that means 3 minus 4. 3 minus 4 is minus 1. So that's why you have minus 1J. So minus 1J, right? Actually, we can also write it as 5 minus J. We can remove the 1. Okay, we can remove the 1. We just write as 5 minus J. Okay, so next one, okay, for the others one, okay, if we deal with the subtraction here, okay, so let's start with the real part. Okay, so 2 minus 3, so which is minus 1. Okay, then next part is the imaginary part, J3 minus again J4. Okay, minus plus. Okay, minus plus. So 3 plus 4, which is 7. So which is J7. Okay, plus J7. Okay, so this is how we deal with the subtraction. Okay, so is that okay so far for addition, subtraction? This one should be easy. Clear?
Yeah, clear, miss.
Okay, then I will move on. Okay, normally addition, subtraction, not an issue. Okay. Okay, so next part. So next part is a multiplication. How we deal with multiplication, division will be different already. Okay, so if you have two sets of the complex numbers, how we multiply them? Okay, so I would like to directly look at the example at the bottom. Okay, so you always remember about this. The J square is equals to minus 1. Okay, when come to multiplication, this is important. J square is minus 1. We are going to apply this, okay, when come to the multiplication. So when we have 3 plus J2, multiply with 4 minus J5, right? Okay. So we multiply as usual. How you expand, okay, the two brackets, okay? So that means 3 times 4. Then 3 multiplied with minus J5. Okay, 3 times 4, you get a 12. Okay, then 3 multiplied with negative 5J, so you get negative J15. Okay, 3 times 5 is 15, so negative J15. Then next, okay, we take J2 times 4. So J2 times 4, right? 4 times 2 is 8, so J8. Okay, then J2 multiply with negative J5. Okay, so you take the number, multiply numbers first. So positive 2 times negative 5 is negative 10. Okay, then J times J is a J square. Okay, so yes, basically it's like how you multiply. For example, if I have a 2 plus 3, it's just like how you multiply for the, like deal with algebra. Okay, so for example, if I have a 3 plus 2x multiplied by 4 minus 5x, it's just like how we multiply this. Okay, how we multiply this. Okay, so when we look at here, right, after we obtain this, okay, minus J squared 10, right, Okay, so we try to simplify it. Okay, we try to simplify it. And then for your information, right? Okay, the j square is actually equals to -1. So when the j square is equals to -1, right? So that means for this part, minus j square times 10 is actually equals to -1 times -1, which is positive. So which is positive 10. Okay, understand? J square is -1, huh? Okay, so minus minus plus. So here is plus 10. That's the only difference. When we do the expansion for 3 plus 2x, 4 minus 5x, right? So when we have a minus 10x squared. So we can't do anything with the x squared, but here is different. J squared is equals to -1. So for the j squared, we will substitute as -1. Then we continue to evaluate it. So become plus 10. So the 12 and the plus 10, we combine, we get 22. 12 plus 10 is 22. Then after that, you have minus j15 and plus 8j. So minus 15 plus 8, then you get minus 7. Okay, minus 7. So which is 22 minus j7. Okay, so it's like a normal expansion. Okay, except the j square here, you have to substitute with -1. Clear? Okay. Okay, clear? Okay, now, before we move on to the division, so you need to understand these terms. Okay, complex conjugate, which is a conjugate of the complex numbers. Okay, so what is a complex conjugate? Okay, so say, okay, complex conjugate is obtained by changing the sign of the imaginary part. Okay, changing the sign of the imaginary part. So for example, you have A plus JB. Can you see A plus JB, the imaginary part is with the sign of plus. So the conjugate will be inverse of the sign, which is minus. That's what we say changing the sign. Okay, so, okay, now, okay, so the complex conjugate for 2 plus 3j is equals to 2 minus 3j. Okay, the complex conjugate for 2 plus 3j is 2 minus 3j. Okay, why is minus 3j? Because as I say just now, we change the sign of the imaginary part. So plus become minus. Okay, so now I ask you a question. What is the complex conjugate of 2 minus 3j?
2 plus 3j.
Yes, 2 plus 3j. Okay, so if you have a minus sign, changing the sign, inverse it, you are going to have a plus. And take note, we only change the sign for imaginary part. It's not the real part, it's an imaginary part. Okay, so this is means by complex conjugate. Okay, complex conjugate. Okay, now, okay, so I assume all of you already understand what is complex conjugate. Then the next thing is I want you to understand, okay, when we have a complex numbers and if we multiply with its complex conjugate, then what is happened? Okay, what is happened? So when you look at 3 plus j4 and 3 minus j4, it's a multiplication of the complex number and its complex conjugate. Okay, so now when we expand this, right, you can see 3 times 3, you get a 9. Okay, then 3 times negative J4, you get negative J12. Then J4 times 3 is a positive J12. Then J4 times negative J4, so you have a negative sign. Then J times J is a J square. 4 times 4 is 16. Okay, then remember the J square, we can replace it as a minus 1. So minus minus become plus. Okay, so plus 16, right? Plus 16. And then minus J12 plus J12, no more, right? 0. So you have a 9 plus 16, which is equals to 25. Okay, which is equals to 25. So as a conclusion, if I have 3 plus J4 multiply the conjugate, its conjugate, it is actually equals to 3 square plus 4 square. Okay, as a conclusion, okay, so the multiplication of the complex numbers with the complex conjugate, you can write it as a square of the real number plus the square of the numbers for the imaginary part. You can ignore the sign, okay, because one must be plus, the others one must be minus. Okay, so you can just calculate as a plus of the 4 square, 3 square plus 4 square. Okay, so as what you can see right here, 3 square plus 4 square, which is 9 plus 16, 25. Okay, so you remember this because later we are going to deal with this one. So that's why here we put in the general A plus JB multiplied with A minus JB, the complex conjugate. So the first one is a complex conjugate of the second complex number, and the second complex number is a conjugate of the first one. So we can just identify which one is a real. Real is a A, so A square plus which one is a imaginary part? B, right? B, so B square. So you can just write it as A square plus B square. Okay, understand? Okay, now, can you tell me this one? Okay, so if I give you this, okay. Okay, can you tell me what is this? How we calculate this?
40.
Okay, so that means the real part is 2 square. The imaginary part, we have a 6 plus 6 square. So 4 plus 36, which is 40. Yes, correct. Okay, so I think you understand. Okay, now, how about this one? One more. Okay, how about this one? How we calculate? Okay, so the real part is negative 4. So that means square of the negative 4. And the imaginary part is a 3. So 3 square. So negative 4 square is a positive. 16 plus 9, which is 25. Yes. Okay. So I can see it in the check box. It is correct. Okay. Get it, guys? Understand?
Yes, miss. Understand.
Yes,
Clear?
miss, understand.
Clear? Okay. Thanks for the feedback. Okay, because you need to understand this for the next part. Okay, how we deal with the division of the complex numbers. Okay. Okay, now, So how we deal with the division of the complex numbers? So it is achieved by multiplying both numerator and denominator by the complex conjugate. Okay, by the complex conjugate. So now let's look at 2 minus j5 divided by 3 plus j4. So we have one complex numbers divided by another complex numbers. Okay, then, okay, so now, which one is a denominator? The denominator is the one at the bottom. 3 plus j4, okay? The complex numbers at the denominator is 3 plus j4. So you need to get the conjugate of the complex numbers at the bottom, okay? So the complex conjugate of the 3 plus j4 is 3 minus j4. Okay, 3 minus j4. We are not referring to the top. We are referring to the one at the bottom. So bottom, we have 3 plus j4. We get the conjugate, which is 3 minus j4. So we have to multiply these complex numbers by 3 minus j4 divided by 3 minus j4. Okay, so now when you look at this, since the top and the bottom is the same thing, so this is equals to 1. So it is fine if we multiply by anything by 1, it will still go back to the same things, okay? So we don't change the values, the equation, okay? Right? Okay, so now let's continue, okay? So denominator multiplied denominator. So now at the bottom, right? At the bottom, you are taking 3 plus j4 multiply 3 minus j4. Okay, remember what I taught you just now, okay? When we have a complex numbers multiply with the complex conjugate, for this part, we calculate by 3 square plus 4 square, okay? So that's why the bottom, we have 3 square plus 4 square. Okay, now you will understand very well why we calculate in this way, okay? Then on the top, okay, on the top is a multiplication of 2 minus j5 and 3 minus j4. Okay, 2 minus j5 times 3 minus j4. So this one we already go through just now, how we deal with the multiplication. So you just expand it as usual. So 2 times 3, we get a 6. Then 2 times negative 4j, we get negative j8. Then followed by, okay, negative j5 times 3, so which is a negative j15. Then negative j5 times negative j4, which is positive j square 20. Okay, positive j square 20. Okay, the only thing is you have to remember to replace the j square as a minus 1. Okay, so minus 1. So I get minus 20. Yeah? So when 6 minus 20, you get negative 14. Okay, then minus j8 minus j5. So minus 8 minus 15, we get minus 23. Okay, so this is what we get. Then the bottom right, we have 25. Can you see what is the reason we multiply with the conjugate just now? Because when we multiply with the complex conjugate, right, at the bottom, we have no more complex numbers. We have a numbers, a real number, no more complex numbers, okay? So with the 25, that means you need to take the real part divided by 25, so which is negative 14 divided by 25. And then the imaginary part divided by 25 as well. So which is minus j23 over 25. Okay, so this is the answer. Okay, in the complex numbers, you may go further by taking the answer as a decimal. Okay, calculate as negative 0.56 and 0.92. Okay, so look at the checkbox. So Samuel say it is like solving surds. Yes, correct. You are right. Okay. Okay, get it, students? Okay. So get the picture right now. Okay, how we deal with the complex numbers. Okay, now I give you this. Okay, let's say, okay, say now I'm, instead of 2 minus J5 divided by 3 plus J4, if I want to have 3 plus J4 divided by 2 minus J5, can you tell me what should I multiply?
2 minus J5.
2 minus J5?
Sorry,
2 plus J5.
2 plus J5, yes, okay. So as I say, we need to look at the denominator. Denominator is 2 minus J5. We get the complex conjugate. So when we get the complex conjugate, okay, so we need to inverse the minus sign. So become 2 plus J5 and 2 plus J5. Okay, then we will continue and so on. Okay, get it, students?
Yes,
Clear?
miss. Yeah, clear.
Okay, so, okay, then we have problem 1. Okay, so this problem 1, right, we are going to have a lot of the calculation to go through. Okay, so I give you an early break. So let's have a 10 minutes break. Then after that, we'll come back for this question. So this one I will demonstrate in the Jamboard. Okay, so give you the break, 10 minutes break. Okay. Okay, so I will see you after 10 minutes. We'll continue with the problems 1. Okay. Okay, students, let's continue. Let me take the attendance. Oh, I just realized some new features. Okay. Okay, take the attendance first.
Look at that. It's like an old.
So this is L4. $3.15, 2 hours. Okay, take your attendance. I thought just now we have 14. Benny? 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 I don't have his name. Okay, let's continue. Okay, don't know where's Benny. Okay, so as I say, we would like to continue with this. So after we go through from the addition, subtraction, multiplication, and division.
Miss,
Yes.
just talked to Banyan. He said that he has an internet issue and he will be here like for 5 minutes.
Oh, he will come back after 5 minutes. Okay.
Yeah.
Okay. Ask him to put a message when he able to join back.
Okay. Here.
Okay,
Here's
thank you.
him, Miss.
Oh, he's here. Okay, you are here, Benny. Okay. Then I take your attendance. Okay, so okay, all present. Okay, now let's continue with the questions that we have. Okay, in the slide. Okay, so you are given three complex numbers, Z1, Z2, and Z3. Okay, this one, Z1, Z2, and Z3. Okay, now, determine in A plus JB form. So you have to determine the following into the Cartesian form. So start with the multiplication for part A. So part A means we have to take Z1 multiply Z2. So Z1 multiply Z2, Z1 is 1 minus J3. Z2 is minus 2 plus J5. Okay, so let's expand this. Okay, so as I mentioned just now, right? Okay, so you just expand it as usual. Okay, so Samuel already done? Okay, so while I discuss, then you double check with your answer. Okay, is that okay, Samuel? Okay, so now let's expand it. Okay, so we have -2, then plus J5, then -2 times -3, which is plus J6, then followed by minus J squared, then 3 times 5 is 15. Okay, so then we have -2 plus J11, then for the minus J squared is -1. Okay, then with a 15, so J squared is -1. Okay, then next, -1 times 15 minus 15 times negative, then is a positive plus 15. So 15 minus 2, which is 13, plus J11. Okay? Samuel, it's okay. You don't need to delete it. Okay, it's fine. Okay. So is it same with your answer, Z1 and Z2, Samuel? 13 plus J11?
I was actually careless, so I actually wrote minus J5, so I got it wrong.
Okay, it's okay. Okay, so because you're not so used to this, okay, yeah, you have to be careful with the sign. Okay. Okay, so -2 plus, okay, to be frank, sometimes I will be careless also, okay? So that's why in exam time for or the test, you better double check. Okay, so this one is plus 15, 15 minus 2, 13, yeah, okay? Okay, now, so is that clear for A, right? Then we proceed to B. So for B, we have Z1 over Z3. Okay, so Z1 is 1 minus J3. Z3 is -3 minus J4. Okay, 1 minus J3 divided by -3 minus J4. Okay, so remember how we deal with it. You need to multiply with the conjugate of the complex numbers at the denominator. Okay, so conjugate of the denominator. Okay, so may I know what is a conjugate of the denominator? Benny, what is a conjugate of the denominator, Benny? Benny, are you here? What is the conjugate of the denominator? You can type in the chat box. Benny drop out again. Okay, so okay, how about Ilalam?
Yes, miss.
Okay, what is a conjugate?
So
For
it's
the-
-3 plus G4.
Okay, correct. -3 plus J4. So at the top, we also multiply by -3 plus J4. Okay, so now, next part. Okay, so how we deal with the one at the bottom. Okay, so we have -3, negative J4 multiplied with the conjugate. Okay, may I know how to calculate the one at the bottom? Okay, can I have, okay, Excel? How to multiply the one at the bottom? Can you tell me? What square plus what square?
-3 square plus 4 square.
Yes, correct. Thank you. Okay, -3 square plus 4 square. So now we need to expand the one at the top. So to expand the one at the top, okay, Cryptacon, can you tell me what is an expansion at the top? Cryptacon? How to expand? You just tell me directly.
You mean like -3 times 1?
Yeah, so 1 times
Yeah,
-3,
1
so
times
it's -3.
-3, then -3 times -j3 become
-3.
j.
So you take 1 times -3, then -3 times -j3, right? Okay, you just tell me what is it.
Positive plus 9j.
Okay, then
Then plus j4. Then minus 12j, j12.
Okay,
J squared 12.
yes, minus j squared 12, correct? Okay, so -3 plus j9 plus j4 minus j squared 12. Okay, correct? Okay, so Cryptocon, what should I substitute for j squared?
-1.
Correct. Okay, you are right. So j squared is actually -1. Okay, so now let's simplify this. Okay, so the one at the bottom, 3 squared plus 4 squared, which is 9 plus 16, 25. So at the top, okay, we have, okay, j squared we replace as -1. So minus and minus plus, so plus 12. Plus 12 minus 3 will be 9. And then J9 plus J4 will be J13. Okay, so what is the next? So the next is each real part and imaginary part have to divide it by 25. So we have J divided by 25 plus J13 over 25. Okay, so this is the answers already. Okay, but we have a choice to actually write it as a fraction or write it as a decimal. So if I write it as a decimal, which is 9 divided by 25, 0.36 plus 13 divided by 25, which is J 0.52. Okay, so this is the answer. Okay. Is that okay? Clear? If any question, you just stop me. Okay, so you understand how to get 9 at the top. Okay?
Yes.
Yes?
After getting the conjugate, right? After multiplying them, like, is it necessary to put -3 square plus 4 square? Or can I just put 3 square plus 4 square? Because earlier you said you don't have to care about the sign.
Oh, okay. So when I say not need to care about the sign, I'm referring to the minus and plus sign for the imaginary part. Okay, so because anyway, because when we come to the multiplication of the complex number and the complex conjugate, right? Definitely one will be the minus sign, the other one will be positive sign for the imaginary part. So j squared will always give us a -1. So anyway, later we will still get a plus. So that's what I'm referring to. Okay, sorry, just I don't make it clear. Okay, but anyway, as you say, okay. So if we put -3 square or we put 3 square, at the end will still the same. Okay, because even I put -3, I know that after I square it, it's still a positive sign. Okay, but I don't want to get students to confuse. So any real values, I will square it. Okay, because just now when I'm telling you a plus bj multiplied by a minus bj, right? Okay, so can you see we emphasize it as a squared plus b squared. So whichever the values of a, you just square it. That's why when the real part is -3, I square the -3. Okay, so when you expand it, right, actually we are taking -3 times -3. Just because of -3 squared, you still get positive. So that's why if you put 3 squared, it's still correct. Okay, but actually supposed to be -3 squared.
Okay, miss, thank you.
Okay, quite a long explanation from me. Okay, okay, now let's move on. Okay, Z1 over Z3, so is done. So we will continue for C. So C is a Z1 multiplied Z2 divided by Z1 plus Z2. Z2. Okay, so Z1 multiplies Z2. We already got the answer earlier. Right? Can you see here? We have the answer for Z1 times Z2, which is 13 plus J11. Okay, then the bottom is Z1 plus Z2, so which is 1 minus J3 plus negative 2 plus J5. Okay, remember how we deal with the addition. So when we deal with the addition, we do it separately for the real part and the imaginary part. Okay, can I have another students to answer this question? Okay, Junho. Okay, Junho, what is the addition at the bottom?
-1
Okay, then
plus J2.
plus J2, yes, correct. Okay, so at the top will be 13 plus J11. Okay, thank you, Junho. Okay, so next we will, okay, after we simplify, now we deal with the division. Okay, now we deal with the division. So I would like to have another students. Okay, Harold. Okay, what should I do when come to the division? So what should I multiply?
-1 minus J2.
Yes, correct. Okay, -1 minus J2. You are right. Okay, so now the next, okay, we will find the values at the bottom. Okay, so to find the value at the bottom, okay, Wei Huan, can you tell me how should I calculate the values at the bottom?
-1 square
Okay, then plus?
plus J squared 2. J squared 4.
Sorry, plus?
I don't know, 4.
Plus 4, which is 2 square. Okay, so because the imaginary part, the value is 2, so 2 square. Okay, -1 square and plus 2 square. Okay, then next one. Okay, at the top. Okay, at the top. Okay, Manheng, how to expand the top? Manheng, are you here, Manheng?
Yes, I'm here. I'm here.
Okay, just tell me. Okay, what is the expansion? What you get before simplify?
-13.
Okay, then
Negative J26
okay,
and negative J11
okay,
and negative J square 22.
okay, correct. Okay, very good. Okay, so that's how we expand it. And remember, okay, so when come to the J square, I substitute as a -1. Okay. Then the bottom, -1 square is 1, plus 2 square is 4, so which is a 5. Okay, so when I expand it, I have plus 22 minus 33, okay, which is a 9. Then minus 26 minus 11, which is J37, okay, divided by 5, okay. Okay, then each one divided by 5. So we get 9 over 5 minus J27 over 5. So this is the answer in the fraction. If we calculate as a decimal.
Miss,
then
37. J37.
Oh, sorry. Thank you. J37. Okay, so equals to 9 divided by 5, 1.8. Okay, then minus 37 divided by 5, 7.4. So J 7.4. Okay, so that's the answer. Okay, understand? Okay, next one. Last question. Okay, so for the last question for part D, which is Z1, Z2, Z3, multiplication of Z1, Z2, Z3. So just now we already have a multiplication of Z1 and Z2 from part A. So we don't need to redo it. Okay, so here. So which is 13 plus J11. Okay, then substitute with J3. J3 is minus 3 minus J4. Okay, now let's expand this. Okay, so can I have next students? Okay, Saad. Okay, can you able to tell me the expansion, Saad? Okay, yeah, maybe you can type in the chat box. Okay, so guys, you all expand this. So, Sa, you can give me the expansion without before simplification. Okay, before you simplify. Okay, so okay, minus 39, yes, 13 times negative 3 minus 39, then minus 52, 13 times 4, okay, yes, minus J52, okay, then minus 33J, yes, the last one. Oh, it's a power. Okay, so next one will be minus J square. Okay, for the last one, okay, you forget to take 11 times 4. They still have a 11 here. Then there's a 4 here. So 11 times 4 is actually 44. Okay, then minus J times J is a J square. Okay, your J square is correct, but it's supposed to be 44. Huh? Okay, 11 times 4. Okay, so next we will simplify this. So negative J52, negative J33 will be negative J85. Okay, then minus J square is a minus 1, then 44, so plus 44. Okay, so plus 44 minus 39, which is 5 minus J85. So this is the answer. Okay? Yep, okay, the answer is correct, Samuel? Okay, 5 minus J85. Okay, so is that clear now? Understand? Clear?
Excuse me, miss.
Yes.
Should it be like negative 13? Oh, okay. Sorry.
It's okay. Okay, clear? Okay. Okay, so any questions before we proceed? So that means now, do you clear on how to do addition, subtraction for complex numbers, how to do multiplication and division also, okay, for the complex numbers, okay? But you have to be very careful, okay? So it's quite tense to do the careless mistake, okay? So especially when we deal with the J square, and when we have some minus sign, positive sign, then you have to be careful to deal with it. Okay, so let's move on, okay? So actually the solution is already given here. Okay, but I think if I explain it again in the board, then will be easier. Okay, so now, now let's move on to the next part. Okay, so how we deal solving some of the problems about complex numbers regarding the unknown. But I think this one is very easy. Okay, so this one is very simple. Huh? Okay, so if we look at this one, how to solve this? Huh? Okay, so if let's say you are given this, an equation, okay? So how we solve for the unknowns of the x and y here, okay? So you have the unknowns of the x and unknown of the y. So, and it's equals to 6 minus j3. So that means for the left-hand side, we need to expand it, okay? So what we have outside of the bracket is just a scalar, okay? So when deal with scalar, this is not a multiplication with the complex number. It's a multiplication with a numbers, scalar. So you just multiply each real part and imaginary part by the 2. So that means I have 2x plus j2y equals to 6 minus j3. Okay, then how we solve for the unknown? Then we compare the real part and the imaginary part. So when we look at the real part, we have 2x equals to 6, where the x is equals to 3. Okay, so if I compare the imaginary part, so I have a 2y, okay, equals to, be careful, left-hand side is a plus, right-hand side is a minus 3. So it should be 2y equals to minus 3. So we have y equals to negative 3 over 2. Okay, so that's how we solve for the unknown. Okay, so is that clear? Comparing the real part and real part, imaginary part and imaginary part. Is that clear?
Yes, Miss, clear.
Okay, then, okay, one more question. Okay, so next questions for part B. You have a multiplication at the left, okay, equals to A plus JB at the right-hand side. So that means you need to expand this part first. Okay, expand this part first. Huh? Okay, how we expand this multiplication? Okay, Ziyi, can you tell me how to expand this?
Negative 2 minus j3
Okay,
minus j4
yes.
and then minus 6j squared.
Okay, correct. Okay, thank you. So it is equals to A plus JB. Huh? Okay, so this is the answers. Okay, then we need to simplify this. Samuel, after simplify, what do we get for the left?
Minus 2 minus j7 and plus 6.
Yes, plus 6. Huh? Okay, so one more step.
Minus, wait, 4, just 4, minus j7.
Okay, yeah, okay.
And a equals 4 and b equals negative 7.
Yes, correct. Okay, right. Okay, so can you see for this one, right? If you first look at it, multiplication, division looks like difficult, but once you understand it, I can see just now when I ask each of you, you can answer very well. Okay, very good. Okay, so that's how we solve it for the unknown. So I think this part should be no problem, right? Okay, so B done. What time is it? Our class until 5:15. Okay, so Next part, okay, so far we have done with the operations on the complex numbers, okay, but all we doing earlier is in the Cartesian form, okay. So now come to this slide. This is about polar form, okay. So remember earlier I told you, okay, when it comes to complex numbers, actually there are three forms. First one is a Cartesian rectangular form that you are very familiar. Okay, so now we will go to polar form. Okay, so polar form is also very important. Okay, because at the end of the topics, we will learn about a theorem, which we call it as a de Moivre's theorem. And the de Moivre's theorem must, when we apply on the complex numbers must be in the polar form. Okay, so now let's look at here. What is means by polar form? Okay, when the complex numbers is in the polar form. Huh? Okay. So, yes, okay. So they say I see sine, cos, tangent. You are right. Okay, so remember earlier I told you how important is a trigonometry. I say trigonometry that you learn in the first topics, right? Okay, you are going to apply it in other topic. Okay, you are going to apply it in other topics again. So here you are going to go through cos, sine, and also arctangent. Okay. Okay, so you see how we relate the first topics. So that's why you cannot let go. You may think that, oh, I already have it in the test one. Okay, then I can just let it go. No, okay. In the future, when come to degree, you are going to, these are the basic topics. You're definitely going to use it again. Okay, it's a background knowledge. Okay, now, polar form. Okay, so polar form of a complex numbers. Okay, so this is the Cartesian form for the complex numbers. Okay, and we can show it in the Argand diagram as this one. Okay, before we come to the diagram. Okay, now okay, so I think I need to explain on this one. Okay, I need to refer to this one. Okay, now let's look at how we actually plot complex numbers in the Argand diagram. So when we have our complex numbers as x plus jy, okay, we plot it as here. Okay, this one is our z. Okay, this is a point. So the x is a real. Okay, then the y is, so here is the y. This one is a y, okay, and here is the x. Okay, so this is your Argand diagram. So you can see jy. Okay, now, so when come to the Argand diagram here, OZ is the R, okay? So can you see from the origin to the complex numbers, the Z, so we call it as a R. We label it as a R. Okay. Then the angle of the OZ, okay, towards the positive real axis, which is theta. Can you see theta here? Okay. So the theta is measured on the positive real axis. So when I say positive real axis is referring to here. Okay. This is positive real axis. Okay. Now, okay. So can you tell me what is the cos theta? Okay, what is the cos theta? By looking at the Argand diagram here. You tell me. Instead of I tell you. Looking at the Argand diagram, what is the cos theta?
X over R.
Yes, correct. Okay. So it's adjacent divided by the hypotenuse. So x over r. So now for cos theta equals to x over r, if you rearrange it, then x will be equals to r cos theta. Okay, r cos theta. So see, that's how I get r cos theta. So the x is equals to r cos theta when come to the complex numbers. The x is referring to the real number, real part. So x is r cos theta. Okay, so now what is the sine theta? Refer to the Argand diagram.
jy over r.
Okay, jy over r. Okay, is it jy over r?
Yes, miss.
Okay. Okay, so we are referring to the values of the y. Okay, so I think the j is confused you. So it should be y over r. Okay, y over r. Okay, so because we are presenting y on the axis, not the j, but we understood that it's an imaginary part. So y over r actually. So if I rewrite this, I can write it as y equals to r sine theta. So can you see x is r cos theta, y is r sine theta. Okay? Okay, so from the Argand diagram, I define what is the x, what is the y. Okay, so now, okay, for z equals to x plus jy, I replace the x as r cos theta. Okay, then I replace the y as r sine theta. Okay, so can you see both parts have a r? So I can write it as r bracket cos theta plus j sine theta. Okay, so this one we call it as a polar form. Okay, this one we call it as a polar form. So we express the complex numbers as in the r cos theta and also sine theta. We call it as a polar form. Okay, okay, so for now, can you understand? Until this part, can you understand? Before I move on. Is that clear until this part?
Miss, just asking, you not necessarily have to factorize to get the polar form, right? You can also leave it as it is, right?
Sorry? Oh, fact, you mean put the r outside of the bracket, is it?
Yeah, is it necessary to do that to get the polar form?
Not necessary. Okay. If you understand this one is also fine. But of course, if it's quite frequent also, we write r outside of the bracket, then you have to understand actually is referring to this. Okay. Okay. Next, okay, next one. Okay, so this is a diagram that we go through just now. Okay, so as I say, okay, so this one is the polar form. Okay, but it's very common that because this one seems to be long. Okay, so usually we will abbreviate this to r angle theta. Okay, it's very common that the polar form, we write it as a r angle theta. So where is the r? The r, which is the r that we defined just now, okay, is a distance from the origin. Okay, it's a distance from the origin to the complex numbers. This distance, we call it as a r. Okay, then the theta, okay, the theta just now from the diagram, right? Okay, so the theta is measured on the real axis, positive real axis. Okay, so that is the theta. The theta is actually this one, referring to this theta. So polar form, we always abbreviated as a r angle theta. Okay, r angle theta for your information. Okay, so now what is the r here? Okay, so the r we actually call it as a modulus or we call it as a magnitude of the complex number. Z is our complex numbers. So the name for the R is a modulus, or we say magnitude. So in the short form, we can also write it as a MOD. MOD is referring to modulus. Modulus of the complex number. So we can write as MODZ, or we write it as a two straight line for the Z, means modulus of the Z, which is a R. Okay, so to determine the R, so can you see the R is actually on a triangle, right angle triangle, right? So this is our R. So this is our Y, this is our X. Okay, so by using the theorem of Pythagoras, okay, the R will be equals to square root of X squared plus Y squared. So I don't think I need to explain this one. Okay, you will understand how to get to this one. So R is square root of X squared plus Y squared. So if I'm referring to the complex numbers, okay, so that means X plus Yj, right? So the X and Y are referring to the values of the real part and the imaginary part. Okay, so the next one about the theta, we have a name for the theta as well. So the theta, we call it as an argument, okay, or amplitude of the Z, okay, but so argument in the short form we put as ARG, okay, ARG for argument, argument of the Z. So argument of the Z, which is referring to the angle, right, the angle measured on the positive x-axis, positive real axis. Okay, so when come to the angles here, okay, as we know, the tangent of the theta, so if let's say this is a theta, the tangent of the theta will be y over x. Okay, so theta will be arctangent of y over x. Okay, so argument of the z, okay, that's why argument of the z is actually equals to theta and is equals to arctangent of y over x. Okay, can you understand this slide? Okay, so that means for this part is about the r, you need to know how to calculate the r and how to calculate the theta. Okay, but when you calculate the theta, right, since we involve arctangent, okay, then you have to be careful. Okay, your complex numbers is in which quadrant? Okay, your complex numbers is in which quadrant? Okay, so for your information, there is a principal value applied for this theta here. Okay, when come to the polar form. Okay, okay, maybe I mention it now. Okay, come to polar form. So as a conclusion, polar form Z is equals to R cos theta plus J sin theta, and always abbreviated as R angle theta. Okay, for your information here, when come to polar form, right, the theta here, we always apply a principal value where the theta is always express it from negative pi to positive pi. Okay, so this is a principal values that we always apply. Okay, the theta is negative pi to positive pi. Okay, that means when you express, okay, the complex numbers in the polar form, okay, so this is the fourth quadrant that we have, right? Okay, so by looking at when we have negative pi to pi means negative pi to 0, then 0 to pi, right? Okay, so 0 to pi is actually 0 to 100 degrees. So when we have positive, remember, positive angles, we always measure our angle from the positive, we always measure our angle from the positive x-axis. Okay, so when we look at negative pi to pi, right? Okay, so 0 to pi positive angle, which is referring from here to here. Okay, 0 to pi, okay, positive. Okay, 0 to pi. So, or we say 0 to 180. So this is positive angle. Okay, anti-clockwise. Okay, measure from positive x-axis with anti-clockwise is a positive angle. Still remember? Okay, then for the positive x-axis, if we measure the angle by clockwise, then it will be negative angle. Okay, so that is from referring to 0 to negative pi. Okay, so this is negative angle. So in other words, okay, so when you want to represent the polar form as r angle theta, okay, as r angle theta, so if your theta is actually in the first and second quadrant, we will express it as a positive angle. Okay, if your theta is in the third and fourth quadrant, we will represent it as a negative angle. Okay, we will represent it as a negative angle. Okay, okay, so this is a part that is a little bit of confuse the students. Okay, sometimes they may forget, but I'm not saying that it's a must. Okay, if you don't actually follow negative angle, it's not wrong also, as long as the angles you put is correct. Okay, represent to the right quadrant. That I just since we say it's a principal value, so that's why when you see how we present the angle, then sometimes you see negative angle, sometimes you see positive angle, then you know why, because of the principal value that we applied here. Okay, I know in the future I need to repeat this again, okay? Okay, so doesn't matter, okay, let's proceed, okay? So that's how we actually calculate our theta, okay, with the different quadrant. Last time we already learned this in the first topic, right? Okay, so how we calculate our angle, okay, so if let's say the angle, basic angle is a theta, then if let's say fall in the first quadrant, we will just measure it as a arctangent of y over x, okay? So basic angle, this one is referring to basic angle. If let's say in the second quadrant, okay, then we have to take 180 minus the angle, the theta. And then if let's say come to the third quadrant, so this is a second, come to the third quadrant, we need to plus. Okay, just a minus. So when come to the last quadrant, quadrant number 4, we have to take 300 minus the angle. So I assume you should know about this because we have gone through earlier. Okay, I hope you still can remember. Okay, now, so let's look at how we find the modulus and argument of the different complex numbers. Which later problem 2 you can see how is how you find the numbers in the polar form, which is in the different quadrant. Okay, now we look at this one first. Try to understand the basic. Okay, so we have a complex numbers that is in 2 plus j3. Okay, 2 plus j3. So the real is 2. Which is on the x-axis. So the imaginary part is j3. 3 is positive. So positive 3 for y, positive 2 for x. So that's why the value is in first quadrant. Understand? Right? Okay. So remember, this is in the x plus jy. Right? X is 2, is a positive. So y is 3 is also positive. When x and y positive, that is in the first quadrant. Can you understand, students? Okay, x and y positive, so that's why it's in first quadrant. Can you understand this?
Yes, miss.
Okay, thank you. Okay, now, So remember, we need to express this as a polar form, okay? So when we want to express it as a polar form, so we need the r, we need the theta, right? So the r is actually equals to square root of x squared plus y squared. So your x is 2, y is 3, so 2 squared plus 3 squared, we get square root of 13, or you can calculate as 3.606, okay? Okay, so this is your r, okay? Okay, then next we need to find the theta, which is the argument of the z, argument of the complex numbers. So argument of the complex numbers, we're taking the arctangent, okay, remember, arctangent of y over x, okay? So the y is 3, x is 2, so arctangent of 3 over 2. So arctangent of 3 over 2, when you calculate, you get 56.31. Okay, 56.31. So for 2 plus j3, right, if I write it in the polar form, it is 3.606 angle 56.31. So this is r angle theta. So which is in the polar form. Okay, can you understand? Right? Can you understand how we write in the polar form?
Can you repeat it, miss?
Okay, so when you require to express, okay, the complex numbers in the polar form, so polar form is in r angle theta. So that means you need to find what is the values of the r, what is the values of the theta. So to find r, so r is actually square root of x squared plus y squared. Okay, so according to your complex numbers, x is 2, y is 3. Okay, so when we substitute into the square root, so 2 squared plus 3 squared, we get square root of 13, which is 3.606. Okay, so can you all understand how we get r? Just now, who is asking me to repeat?
Me, miss. Yeah, I get it, okay?
Okay, R, you get it, huh? Okay,
Yeah.
so next is a theta. Okay, so theta, this is the theta, right? This is a theta. So theta is actually 5 by arctangent of y over x. So again, the y and x are referring to the 3 and also 2. Okay, so arctangent of 3 over 2, when you calculate, you get 56.31. Okay, 56.31. Okay, now since your complex numbers is in the first quadrant, okay, so your theta is actually 56.31. Okay, 56.31. So now to express the complex numbers in the polar form, so the r, which is 3.606, then the theta, which is 56.31. Okay, so is that okay? Is it Ilalam?
Yeah, miss. Yeah, okay, I get it.
Okay. Okay, good. Okay, so that's how we express it in the polar form. Okay. Now, okay, so now we have the following complex numbers. Okay, so express the following complex numbers in the polar form. Okay, in the polar form. Okay, so now, okay, when you look at the four numbers, four complex numbers that we have. Okay, so just now, one of the complex number is 3 plus j4. So remember, this is x plus jy. So the x is 3, y is 4. So both x and y are positive. So it is in the first quadrant. Okay, when you plot in the Argand diagram, it is in the first quadrant. Okay, then come to minus 3 plus j4. Okay, so this is x, this is y. So x is negative, y is positive. That means your complex numbers is in the second quadrant. Okay, then next, okay, so when come to the third complex numbers, you have minus 3 minus j4. So the x is negative, y is also negative. That is happen in the third quadrant. Okay, then the last we have x is positive, y as a negative. So that is in the fourth quadrant. Okay, that is in the fourth quadrant. Okay, so now, okay, if we want to represent these complex numbers in the polar form, remember, polar form, okay, is in r angle theta. So that means you need to find r, you need to find theta if you want to present the complex numbers in polar form. Okay, so the r is actually equals to x squared plus y squared. So now if I want to present the polar form for 3 plus j4, right? Okay, so the 3 is a x, y is a 4. So which is 3 squared plus 4 squared, which is 5. Okay, then when you calculate the angle, okay, so theta is actually arctangent of y over x. Okay, so the y which is 4, the x which is 3, right? So which is arctangent of 4 over 3 when you calculate is 53.13. Okay, so 3 plus j4, can you see 3 plus j4 is in the first quadrant? Okay, first quadrant, and the angle you get 53.13 is in the first quadrant. So you can present the complex numbers as, okay, r which is 5, then the theta which is 53.13. Okay, 5 angle 53.13. So this is in the first quadrant. Okay, so quadrant number 1, okay. Okay, now let's move on to other complex number. Okay, so come to other complex numbers. Okay, negative 3 plus j4. Okay, so by referring to negative 3 plus j4, okay, so remember this is negative 3 plus j4 is in the second quadrant. Okay, so this is in the second quadrant. So that means, okay, so this one is in the second quadrant. Quadrant number 2. Okay, so as I say, when we want to present in polar form, we need what? We need r. Okay, so how we calculate r? So remember just now? Okay, r is actually square root of x squared plus y squared. So your x is minus 3. Your 4, your imaginary y is 4. So it's a square root of 25, which is equals to 5. Okay, for your information, so all these, the r are 5, because the real and the imaginary part, they are 3 and 4, just a different sign. But when come to different sign, when you square it, it's always get a positive, okay? So your r will be 5 for all of these complex numbers. Okay, so now we get r equals to 5. So remember earlier, when we calculate for arctangent of 4 over 3, you get 53.13. Okay, you get 53.13. So now, for this minus 3 plus j4, it's happened in the second quadrant. Okay, it's happened in the second quadrant. So when it is happened in the second quadrant, okay, so that your r is still the same because the length of the r is actually measured from the origin to the complex number. So the r is always the same. But the angle, then you have to take note, the angle is measured from here to here. Okay, so from here to here is in the second quadrant. So when it is in second quadrant, you have to take 180 minus the 53.13, so which is 126.87. Okay, then when you write your complex numbers in the polar form, r angle theta, then your r is 5, your theta is 126.87, which is happened in the second quadrant. Okay, which is happened in the second quadrant. Okay. Okay, now for part C. Okay, so part C, we have negative 3 minus J4. Okay, so negative 3 minus J4. So if we refer to negative 3 minus J4, it is in the third quadrant. Okay, it's in the third quadrant. So, okay, quadrant 3. Okay, third quadrant. So when it is in the third quadrant, okay, so this is a complex numbers. As I say, the R is always the same. Okay, but now come to the angle. The angle is actually from here to here. Okay, so when the angle is from here to here, so that means you have to take 180 degree plus 53.13. Okay, plus 53.13, so you get 233.13. Okay, so when you write your answers, R which is 5, angle which is 233.13. Okay, but we also write the angle as a negative 126.87. Okay, remember just now I told you the principal value, right? So the principal value, okay, so when come to the principal value, when the angle fall into the third quadrant, right? So we can express it as a negative angle, okay? So remember the basic angle is 53.13. So that means here is 53.13, okay? Then how you get your angle, the negative angle, which is measured from here? Okay, so that means we have to take 180 minus 53.13. So you will get 126.87. Okay, the angle is 126.87. But since when we measure from here with the clockwise, then it will be negative 126.87. Okay, negative 126.87. So that's why we can express it as 5 angle negative 126.87. Okay, so is that okay? Oh, okay, 516 already. Okay, I move on faster for D. Okay, D is 3 minus J4. 3 minus J4 with the X of positive, Y is negative, is 4 into the fourth quadrant. Okay, 4 into the fourth quadrant. So when come to the fourth quadrant, okay, so this is the fourth quadrant, okay, and the basic angle is actually 53.13. Okay, so remember when come to fourth quadrant and third quadrant, we measure the angle as a negative angle. So if I measure from here with the clockwise, okay, with the clockwise, then it will be minus 53.13. Then the R is still the same because the length of the R is always the same, so which is 5. Okay, so that's how we express it in the polar form. Okay, so that's how when come to different quadrant, right? Okay, the angle must reflect on which quadrant they are. Okay, so that's why okay, if you represent as positive angle, we can see. If you represent as a negative angle, we can also able to see which quadrant is the complex numbers. Okay.
Hi, Miss. I would like to
Yes.
ask
Okay.
the D. Why C got 2, D only got 1?
Okay, so it's not 2 or 1. Okay, so can you see? As I say just now, according to the principal value, when come to third and fourth quadrant, we always represent the angle as negative, okay? Negative angle. So that's why this is negative 126.87. But if you want to present it as a third quadrant, so it's actually same as an angle of 233.13. So that means for the last one, right? If I want to represent as positive angle, it's also correct. So if I measure it as a positive angle, then I need to calculate 360 minus 53.13. So 360 minus 53.13, then which is 306.87. Okay, So it is also correct if I measure it, if I express it as 5 angle 306.87. But because of the principal values that we always apply, okay, the angle must be, here, can you see? Okay, the angle must be negative pi to pi. So that's why when come to fourth quadrant, normally you can see that's how we express it. But if we measure in the positive angle, this is the answer. Okay, so same concept as the third quadrant.
Yeah, Miss, I was actually just about to ask about why did it exceed the principal value, but you answer all the question already. Thanks, Miss.
Okay, yeah, okay. Okay, so I think that's all for today. Then you have questions to practice. Oh, there's a lot of the questions. Hold on now, whether I finish polar form. Okay, you can do up to 7, number 1 to number 7. Luckily, I only see you next week. Okay, so you should have time to practice it. So practice question 1 to 7. Okay, after you go through complex numbers, so you don't think matrix is a hassle, right? Okay, so practice question 1 to 7. As I say, this is something new to you. Practice means perfect lah. Okay, it will definitely make you understand better. Okay, okay. So yeah, it's already 5:20 already. I already take an additional 5 minutes from you. So I think that's all for today. So I will see you next week. So next Monday, we will just focus on the tutorial. I think only tutorial itself. I think the 7 questions will take 2 hours for our tutorial. Okay, so have fun with the 7 questions of your tutorial. So I will see you next Monday. Okay, bye students.
Thank you, Miss.
Yes,
Bye.
thank you, Miss.
Bye-bye. Have a
Thank you,
nice
Miss.
day.
Thank you, Miss. Bye-bye.
Bye-bye.
Thank you, Miss.
Yep, welcome. Bye.